The following presentation is about graphing sine functions. The general equation for a sine function is y equals a sine, parentheses, b, x minus c, close parentheses, plus d, where a is the amplitude or height of the graph, b changes the period is going to be equal to 2 pi over b, and again that's the length of one cycle. The c value is the horizontal shift. That's where the cycle starts. It's going to be at the opposite sign of the c value. And d is the vertical shift, which is the location for the midline of the graph. So here we have one cycle of the standard sine function. The cycle starts here and it ends here. The length of the cycle is the period. And this length is going to be equal to 2 pi over b. The midline, which is equal to the d value, cuts right across the middle of the curve. The amplitude is the distance from the midline to the highest and lowest points. And then the cycle is going to start at x equals the c value. Graph y equals 3 sine 1/2 x minus pi over 4 minus 1. So the first thing we are going to do is we are going to label all of the important pieces of information that need to go on our graph. We're going to sort through the information. So first we have the amplitude is going to be equal to 3. The midline is going to be the d value, which is y equals -1. The cycle starts at the opposite of the c value. So if it's negative pi over 4, we're going to start our cycle at positive pi over 4. And then the period is going to be equal to 2 pi over b. b is 1/2, so our period is going to be equal to 4 pi. For our sine function, I'm just going to lay out the general pattern of the points, connect them in the curve, and then determine all of the coordinate points for my sine curve. The first thing I'm going to do is I'm going to put the midline on my graph and label it with its equation. So the midline cuts through the middle of the graph, and the equation is y equals -1. The most challenging part of the sine and cosine graphs is figuring out the x values for the function. So the x coordinates, what we're going to do is we're going to add 1/4 of the period to the previous value. So if the distance from the start and where it ends is a period, this would be half the period, and then the distance from where we start to the first time it reaches the amplitude is 1/4 of the period. So if my period is equal to pi over 4, then 1/4 of 4 pi is equal to pi. So we know that our cycle starts here at the c value. So my first x value is pi over 4. and then I'm going to add pi to my initial value. I'm going to need a common denominator, so I'm rewriting pi as 4 pi over 4. Add these two values together to get 5 pi over 4. So again, I started at 5 pi over 4. My next x value is 5 pi over 4. And then I'm going to keep adding a quarter of the period until I reach the end. So the third x value is going to be 9 pi over 4. And then we have 13 pi over 4. And then the last is going to be 17 pi over 4. Now I have enough information to start labeling the points. So my x-coordinate of the first point is pi over 4. My y-coordinate is going to be the location of the midline. The next point, I have 5 pi over 4. The y value is going to be the midline plus 3. That will give me a y value equal to 2. 9 pi over 4 is the third coordinate point, and we are back at the midline of -1 for the y height. 13 pi over 4, I am going to drop down a height of 3 on the vertical axis to give me a y coordinate of -4. And then lastly, we are at 17 pi over 4, -1. And this is the complete graph for y equals 3 sine 1/2 x minus 4, or x minus pi over 4 minus 1. So again, this is just one cycle. We're going to do another example. I'm going to try to graph y equals negative sine 2 parentheses x plus pi plus +4. The biggest difference between this one is our amplitude is going to be, since I don't have a coefficient here, it's going to be 1. But this negative means we are going to reflect the graph. The midline is still at the d value, so y equals 4 from right here. The cycle is going to start at the opposite of the c value. So the opposite of the c value is x equals -pi. The period is 2 pi over b. b is equal to 2, so our period is going to be equal to pi. Since this graph is reflected, instead of having a function that initially goes up, we are going to have a function that is initially decreasing. Aside from that, the pattern stays the same, except for we're going down first, turn around, up, and then back down. The x values for my graph. The cycle starts at -pi. A fourth of the period is going to be pi over 4. First x value is at -3 pi over 4. Sorry, that would be the second one. We already have the first one. First one's at -pi. Second one is at -3 pi over 4. The third one is going to be at -2 pi over 4. I will reduce this once I put it on my graph. The next point is at -pi over 4, and the last point is going to be at an x value of 0. I already have my general form of the curve for sine. Next thing that's going to go on my graph is the midline. The location of this midline is y equals 4. My first coordinate point is going to be negative pi, comma 4, because we're at the midline. The next one is negative 3 pi over 4, and I drop down an amplitude of 1. So my y height of the coordinate is 3. Negative pi over 4 is going to reduce to negative pi over 2. We are back at the midline. Negative pi over 4 is the next coordinate point. We're going to go up the amplitude to give me a y height of 5. And the last coordinate point is going to be back at the midline with an x coordinate equal to 0. And that concludes our presentation on graphing the sine function.